Okay, so welcome to question 3, 2016, paper 2. Okay, so just look at this question here again. Like I try to say at the start of every video, make sure you pause this and try the question in advance. But what we have here is obviously a circle question, so part of coordinate geometry. And I put in an infographic here showing the equation of a circle. Now, that's the equation of a circle with center HK, so basically not 0, 0. If that um, center was 0, 0, the h and the k would be gone. You'd be left at x squared plus y squared equals r squared. Okay, so there's the two formulas that you'll be focusing on. Now, just to show you where they are, I should have it open. I have it here on the maths tables, page 19. Part of the coordinate geometry section, you have the equation of the circle formula. There's other formulae there. I've seen some people use them in the past level, but they're often not the right formula, and it's not the answer the examiner's looking for. So really, the only formula you should be using in conjunction with the circle itself is this formula. Maybe you have to do distance formulas, other things, but that's the main formula. It's what we're using right here. So let's get stuck in. Okay, so obviously we said circle. Okay, it has center 2 minus 3. Now that would be given the representation h and k. I don't know why it's h and k, but that's what they are. And a radius of 4 centimeters, so r is equal to 4. So we have 3 inputs into the formula, so we'll go straight to the answer. So that's the formula written out. So you have your h, that's the 2, and you have your k, that's the minus 3, and you have your r as the 4. Okay. So put the numbers in now. I put in the negative number in brackets. You could put both in, but minus by a plus is always going to stay minus, so it doesn't really affect anything. Whereas minus by a minus would change that to positive, so it's good to put in brackets to remind yourself that you have to do that. So I put the things in. Okay, go left to right then once you've substituted in the values. Remove brackets, so minus by minus gives you the plus 3 here. Now they want you to go the further step of not leaving that as 4 squared, of moving it to the actual 16. Sometimes they deduct a mark or to go back a step. So make sure you do square that. Job done. Okay, so I'll move on. Now again, pause it now. Just give this your best shot, okay? So assume you're back. Draw the circle C on the grid opposite. So it's an XY diagonal labeled. Each unit on the coordinate grid is 1 centimeter. I'm assuming they're telling us that to something to do with later on an actual measurement or find the area or something to that effect. But our center HK was 2 minus 3. So 2 on the X minus 3 on the Y, that would be the center. You're then measuring 4 units because the radius is 4. So 1, 2, 3, 4. That's where you put your compass. Draw your circle. Okay, now I'm not going to draw with this pen thing because it'll make it an absolute disaster of it. But that's what it would look like there. Okay. Now, the second part then, part C. Verify using algebra that the point 3, 1 is outside of circle C. Now, there's 3 things they can ask here. Basically, is the point inside the circle, on the circle, or outside the circle? And it's the same thing, just depending on what the answer is. Now, I would suggest you have the point 3, 1. I would suggest you label it. Okay, so mark it clearly on the diagram and put the label 3, 1 here. Now, by doing that, you definitely have the attempt. Okay, so I'm going to use the formula that we got for part A. Now, whatever answer you got in part A, you can use here. So even if you couldn't do it, you made up an answer, it'll be accepted as correct. So I'm putting 3 instead of the X, 1 instead of the Y. And ultimately what's going to happen here is if the left-hand side of this equation works out to be less than 16, the point is inside the circle. If it's equal to 16, it's on the circle. If it's greater than 16, it's outside. Now, we could probably see from there that 3, 1 is very, very close to the circle, but it's not actually on the circle, okay? So I put in my points in. So 3 instead of the X, 1 instead of the Y. Put through the calculator, okay? I've done a piecemeal step by step, but I end up with the answer 17 is greater than 16. So my conclusion then is the point is outside the circle. So I've proven it. I need to always say, even though this is a mathematical statement, I need to say it in English. So verified, true, outside, whatever. way you want to phrase it, as long as it indicates outside or acceptance of the statement, you're going to have full marks. Okay, so that's part C. Now, part D then says find the area of the smallest four-sided figure that will fit around the circle. Not inside, but around. Biggest mistake made this year, or that year, so last year. What people just, they didn't, I suppose, maybe cop that, and they drew a box inside the circle. Okay, I'm going to go straight to the answer just to have so it looks right. Okay, so that's the smallest box around the circle. Now, if you cop it, okay, if you count the number of each box is 1 centimeter, so that's 8. So is that. Okay, the area of a square is length by length. Okay, so it's 8 times 8, which is 64. Now, units are important. It's square units, and there were centimeters we start off with, so centimeters squared. You'll usually lose a mark for not including the units, so units are really, really, really important. And that should be that. Okay, so yeah, okay, so I'll stop there. Again, have a look back in a few days' time and make sure that you're able to do that. The circle question is a lovely